Hi guys, in this video I'm going to show you how to test the LEDs in a backlit LED screen TV without disassembling all the screen, which is the most common mistake people make, as they take all the screen to bits to see if there's an LED faulty, when actually it's not necessary at all. So the first thing we're going to do, I've already measured the forward voltage, which is very important on the screen. It's 68 volts, it's a Vestel VS315 WNDL. At 68 volts this screen will draw 100 milliamps. So the first thing we're going to do now is connect that to a power supply. I've set the power supply there. You can see the current reading there. We're going to draw 100 milliamps at just approximately 68 volt in the digital meter. Right, so the first thing we want to do is take this connector and plug it into there, making sure we get the right polarity. And there we go, the screen's lit up. If you go to the front, it's very bright, but you can see all the LEDs are lit up. And if we look at the power supply now, 68 volt, and we're drawing a current of 100 milliamp through the LEDs. So that is a good screen. That would tell you, that's a good indication the screen's okay, without taking it all to bits. Right, I'll just stop the camera. Right, now I've swapped that screen for another one. It's an identical screen, but this is a faulty one. So I'm going to power this up and I'll show you what happens to this one. Right, so the screen's lit up. Now the first thing you'll notice is the actual current on the meter is changing. There, the forward voltage is 68 volts, exactly the same, but if you look at the current reading, the set is now drawing, the lights are now drawing a lot more than 100 milliamp, which they should be. And if we move to the front, you'll see there are 1, 2, 3, 4 LEDs not lit. So that's one of the tests, is actually measure what current the screen should be taking. Now it's drawing now about 130 milliamps, which is 30 milliamps more than what it should be, and the current's changing there through the LEDs. And you might even be able to see, no, you can't see it flickering. Right, okay, so I'll swap the screen for a couple of LED strips just to give you a quick demonstration. One's working, one's faulty, and I'm going to show you now why the forward voltage of the screen is very, very important, and you can actually test the screen without taking it all to bits. So what I'm going to do is I've got this cheap Chinese LED screen tester. You can see the voltage on there, 296 volt. That will drop when we connect the LEDs, and that is going to display the forward voltage of the LED strip. So taking each LED to be about 2.8 volts, there's 11 on this strip, that should be lit about 30 volts. So just get that into that. Okay, so that's the LEDs lit. You just got to wait for them to come up to brightness. Takes a few seconds. And right, that's about stabilised now. So if we look at the tester now, you've got the forward voltage of 31.2 volts, which is about right for that length of strip. Now what I'm going to do is I'm going to unplug the strip, I'm going to swap it for an identical one which is faulty, and then we'll see what the forward voltage is on the faulty set. Right, okay, I've swapped over the strips for a faulty set. I'm just going to connect this up here. There we go, that's the faulty set, and straight away you can see these two LEDs not lit. That one and the one at the very end, which I've marked with a bit of blue pen. So we'll just wait for them to come up to brightness, which is about there. Right, now if you look at the forward voltage now, it's varying with 111, 112 volts forward volts. Now it's gone down to 80, but you can see it's varying all the time. It's a lot more than the 30 volts forward voltage per strip. So if you put this into a TV, the chances are it would not light at all. It'll just trip the over voltage protection on the output of the boost converter, because with a boost converter, when there's no load, the output will just keep rising and rising until the MOSFET's destroyed. So on the output of the boost converter there's a potential divider. There's a diagram. The potential divider there, a couple of resistors, and that is fed back to the controller chip. So if the voltage here exceeds about 100 volts, then the circuit just switches off, and the output from the boost converter, where you should have about between 60 and 80, will drop back to the input of 24 volt. So as soon as that point there exceeds the OVP trip level, the whole of the set will switch off and the LEDs will go off. So if we go back to that again, you'll see on the strip with a forward voltage of 120 volts. Well, it's varying all the time, but it's over 100. So you put this in the set and that would not even light at all. You might get a flicker as the LEDs light up, the screen flashes, but the screen would not illuminate, it'll go dark, and the boost converter switches off. See, the forward voltage has dropped now. Well, it's varying. So that is another test you can do. You connect your tester across the screen. If you look on the internet, you'll be able to see how many, probably get a picture up of how many LEDs are in the screen, and by that you can work out what your forward voltage of your screen should be. Then when you come to test it, if there's any variation on there, it tells you that there's an LED out, and that is without taking all the screen to bits. Right, just one more little quick demonstration. I've swapped this screen for a 40. I've swapped the screen for a 40-inch one. Now, if you look on there, we're feeding 150 volts into the screen, and it's only drawing 10 milliamp. So that is another clear indication the LEDs in the screen are done. If you look at the screen, it is actually lit. It's not very bright, it's lit. But with 150 volts, a current consumption of 10 milliamps is far too low. So that's another indication inside the screen is a high resistance LED. Now we might be able to, if we increase the voltage a little bit, we might be able to get the LED that's faulty to short out a bit. So let's give that a go and see what happens. There we go. Now 155 volts, it's drawing nearly 200 milliamp, and you can see the current meter going up and down, and also if we were to look at the screen you'd see it flickering. That's another clear indication we've got one or more faulty LEDs in the screen, and that is again without taking it to bits. Yeah, just see it flickering there, and that corresponds with the current's dropped back down now to about 10 milliamps. So there you go, that's how you test the LEDs in the screen without disassembling it all. Voltmeter, power supply, or just a cheap Chinese LCD screen testing tool.